Alright, you can write this stuff if you want. It's not super necessary. It should be stuff you know anyway, but I want to review it with you. That's why it's called background. Now, am I correct in assuming that you all know the square root of 25 is 5? Okay, good. Woo!
Wait, how does that equal 6?
No, it's 620. You can't see it. It's 625. But why is the square root of 25 equal to 5? Because 5 times 5, you have to have 2 of them. 5 times 5 is 25. 2 of them because it's a square root. You may not be as familiar with cube roots and fourth roots, but did you know that 5 is also the cube root of 125? But why is that? 5 times 5 times 5 is equal to 125. There's 3 of them, 5 times 5 times 5, hence the cube root. Man, this 5 is an awesome number. 5 is also the fourth root of 625 because 5 times 5 times 5 times 5 is 625. This is all stuff that you should be able to easily understand, stuff you might already know. I do want you to write this in your notes. You see what I'm circling? This is pretty quick to write. 4.1, roots and radical expressions. But
is there a way to do like the cube root on the calculator?
Yes, I'll talk about that in just a second. That's an excellent question. You see what happens when you put your book away? You have all these good questions.
Yeah.
But the square root of 25 equals 5 because the exact opposite has to be true. Now, I need you to stop for just a second. I'll let you write, but I need you to listen to this, what I just said. What is the exact opposite of the square root? Squaring, right? So in order for the square root of 25 to equal 5, it also has to be true that 5 squared equals 25. Is that true? Okay, that's what I mean by the opposite. And the same thing with this. You see where my pencil is? What does that little 3 mean? Cube root. So you remember when I said the index of a radical? Remember when I said that at the beginning? That's what I meant. This little 3, what do you call that guy? The index. That's the index. So the cube root of 125 is 5 because the opposite is true. 5 cubed is 125. And so on and so on. Write this one as well. The fourth root of 625 is 5 because if you do the opposite, 5 to the 4th power, that equals 625. Now, like I said earlier, you guys are experts at square roots. If I started popping off square roots, you guys could answer them immediately. Square root of 81. That wasn't immediate. Come on. Square root of 100. Ooh, there you go. 121. Square root of 4. Square root of 0. So you guys are pretty good at square roots. But what about cube roots? Do we think we're as good as cube roots? What are some of the, like 4 and 9 and 16, those are perfect squares because they have square roots. What are some of the perfect cube numbers?
8.
Why 8? 8 is 2 times 2 times 2. So 8 is a perfect cube. What's the cube root of 8? 2. 27's another one. How come 27? It's 3 times 3 times... So if I ask you guys what's the cube root of 27, you would all say 3. What's another one?
4. 64.
64. Because that's 4 times 4. So if I ask you guys the cube root of 64, or if I ask Mason back there who's paying excellent attention, you would say 4. Okay? Now Austin, I do that every time. Dallin asked about cube roots on a calculator. You can do cube roots on a calculator. Turn them up.
You didn't even know us.
I had him as a student.
I don't remember you.
Ask him again. So, before we do cube roots, we better make sure that you know how to do square roots. You know how to do square roots on a calculator? You hit second, and then the x squared, and then you can type in whatever you want. Square root of 81 equals 9. So that's how square roots work. Here's where the cube root is. You ready? Hit the math button. Do you see where my mouse is pointing? It says math. Hit the math button.
So if it's more than 3, would you go to the fifth one instead of the fourth one?
Do you see that little 3 in front of the root? That's the cube root. So hit option 4. Look at that. So let's do one that we already know the answer to. What's the cube root of 8? Let's see if the calculator is as smart as we are. Oh, alright, it is. That's how cube roots work. Your calculator can do 4th roots and 5th roots and 6th roots, but you have to know the correct buttons to push. You ready? Here's what you do if you want a 4th root. You first have to type the index. If I want to do a 4th root, what's the index? 4. So type the number 4. Now go back to the math menu. Do you see option 5? The little X thing? That means that X is going to become whatever number you have just typed in. So this is what mine looks like now. Hey, a 4th root, yay! If you have a little bit older operating system, then it'll have the big 4 then a little X thing. It means the same thing. Now, we don't know any 4th roots. What's the first 4th root number we can think of? 16, because it's 2 times 2 times 2. So let's type in 16. 4th root is 16. What do we think it should be? 2. Look at that. So, does that answer your question down on how to use a calculator? I don't mind if you use these calculators. They're free game. You can use them as you feel fit. Sometimes it is quicker not to use them. But anyway, here's some more background. And you may not need to write this. If you already are pretty familiar with this, then maybe you don't need to write it. But what's the square root of 16? Come on. What's the square root of negative 16? So it is 4i, but I is imaginary. So does the square root of 16 really exist? Or does the square root of negative 16 really exist? Why not? But yes, because it's imaginary, but why? Exactly. Maybe we should write this. The square root of negative 16 doesn't exist because nothing times itself equals negative 16. Unless you use imaginary numbers. And even our calculators, as smart as they are, it can't even square root negative numbers. Check this out. Square root of negative 16. What do you think it's going to do?
Actually, there are certain calculators that can do that.
Non-real answer. There are some that could. But it says non-real. That means it doesn't exist. It's imaginary. And you know that. I know you know that. All right, you ready for this? You thinkers out there? What's the... Well, didn't we just do a 4th root of 16? What was the 4th root of 16? You remember I had it on my calculator? It was 2, wasn't it? All right, listen carefully. What's the 4th root of negative 16?
2.
Is there a 4th root of negative 16? Is there well, let me rephrase that. Is there a real number that's the 4th root of negative 16?
Well, yes.
Why not? If you multiply a number with itself 4 times, is it ever going to equal negative 16? It's going to equal positive something, right? So we can't take the square root of negative 16. We can't take the 4th root of negative 16. Do you see a pattern here? Evens. You cannot even root a negative number. Okay, but where you got to be careful is, what's the cube root of negative 8? Do you see what I'm asking? What's a number times itself 3 times that could equal negative 8? Is it 2 or is it, what's 2 multiplied with itself 3 times? That's positive 8, right? So it's not 2, we want it to equal negative 8. What about negative 2? Because negative 2 times negative 2 is positive 4, but then another negative 2 would make it Negative 8. So is it possible to cube root negative 8? Yeah. The answer is negative 2. So how do we know when it is possible to do negatives and when it isn't? When what's odd? The index. We need to write that down. If the index is odd, then you can find the root of a negative number. Isn't math awesome? It absolutely is.
That's what used to be.
Mental abuse to humans, huh? I actually would argue with that. I think Twilight is mental abuse to humans. That would be like a punishment a judge would hand out. You steal something, I sentence you to read Twilight. No, please, I'll do anything. Don't make me do that. Even worse would have to be to watch the movies. That would solve a lot of crime. If criminals knew that they would have to read one of those books, they wouldn't do a lot of the stuff they do. Yeah. A lot of them probably couldn't read, though. They'd have to watch the movie, which is even actually worse. Until Jacob takes off his shirt, and then it just, you know.
You know this is recorded.
Yeah. Now this, yeah, I should have edited that, right? This you might not be as familiar with, so you do need to write this down because it makes a difference on your homework. You remember when I asked you what the square root of, what was it? What's the square root of 25? That's not entirely correct. It's really plus or minus 5, isn't it? Because what's negative 5 times negative 5? That's also positive 25. So the way that the homework distinguishes is there's something called the principal square root.
Can you hopefully go a little to the right?
That's normally what we think of when I ask you a square root.
It's down. Just go to the right.
So if you're just asked to simplify something, usually what they mean is the principal square root. So if I ask you to simplify square root of 64, what's the square root of 64? 8. That's the principal square root. It's the positive number. But technically that's not all of the roots. You understand me? So if they want all of the roots, they would ask this question. And this is what your homework's going to ask most of the time. Find the real roots of 25, or the real square roots. What are the real square roots of 25? 5 and negative. You see the difference there? So you just need to make sure you read the directions. So if they want the real roots, then that could also include the negative. But you got to be careful before you just start putting plus and minus signs in front of this. You ready? What are the real roots of, what are the real square roots of 9? 3 and negative 3. Okay. What are the real cube roots of 8? Well, let's be careful on how we answer this. What are the real cube roots of 8? It's just 2. It's just 2. How come not negative 2? That would equal negative 8 when you multiply it 3 times. Do you see the difference there? Let me ask you again. What are the real square roots of 36? 6 and negative 6. But what are the real cube roots? You listening? What are the real cube roots of negative 27? Just negative 3. Because what's negative 3 times negative 3 times negative 3? Negative 27. That's the only number. So sometimes real roots means you can have more than one. Sometimes real roots mean you just have one. Okay, just be aware of that. Read the directions. So let's go to your books and actually practice some of this awesomeness. Go to page 232, where it says problem 1. Got it? Do you see which one I'm talking about?
A, B, or C?
Let's do part A. Part A asks, what are the real, what is it, fifth root? What are the real fifth roots of 0, -1? So you can write it this way. You don't have to write out the phrase real fifth roots. You can write it like this. Look at the answers. You guys are a bunch of cheaters. What's the fifth root of 0, the fifth root of -1, and the fifth root of 32? Now, we don't need calculators for these, so put them away. The first one there ought to be fairly obvious. What number multiplied with itself 5 times equals 0? 0. The real fifth roots of 0 are just 0. You got to think for a minute here about the fifth root of -1. What number multiplied by itself 5 times could ever equal -1? Just -1, right? So the fifth root of -1 is -1. And I suppose we could verify that if we need to on a calculator. Do you remember how to do a fifth root? Type in 5. Math. Option 5. -1. Ooh, I hope we were right. That would be embarrassing if we weren't. Whew, -1. There we go. What about the fifth root of 32?
It'd be 2.
It'd be 2. Just 2?
Yeah.
Just 2. Yep.
So, we better write these down. What did we say this one was? 0, -1, and 2. All right, we're on a roll.
Let's do part B. This one you may have to get out your calculator, you may not. So, what are these? What does it ask? Square roots, right? The real square roots of 0.01, the real square roots of -1, and the real square roots of 36 over 121. So like I said, you're welcome to use your calculators on these. That would be fine. But just know your calculator might not give you all of the real square roots. It may only give you one of them. Did anybody get the square root of 0.01? 0.1? But you got to think for a minute. There, they want the real square root, so it's got to be plus or minus 0.1. Isn't that what the question says?
Yeah.
On part B, what are the real square roots?
So, this one was plus or minus 0.1. Square root of -1. Remember, it wants the real square roots. I isn't a real number. This one just doesn't work. There aren't any real square roots of -1. There are imaginary. But this one you would just say not real.
Because nothing times itself is ever going to equal -1. Unless you use imaginary numbers. I want you guys to watch me on the third part of part B. Check it out. Square root of 36 divided by 121. Your calculator is going to give you a decimal. That's not going to fly on your homework. It's going to want a fraction.
That's the fraction button, Mason.
Where is the fraction button? Math,
I think you don't need more directions.
and then frac, and then enter again, Now I want you to look at your answer compared to what we started with. Could this have been done without a calculator? Look at your answer compared to what the question was. The answer is 6 over 11. What does it have to do with anything?
Square root of 36 is the square root of 121. So square rooting fractions is easy. You square the top and then you square the bottom. So
Why don't you just do it all at once?
these two things mean the same thing. The square root of one fraction is the same thing as two separate fractions on the top and bottom. Anyway, the answer is not just 6 over 11. It's plus or minus 6 over 11. Not that it really matters, but for those of you that are a little more comfortable with fractions, this one right here could also have been done without a calculator. Check it out. Isn't 0.01 just 1/100th? What's the square root of 1/100th? 1 over 10, which is 0.1. So those could also be done. Well, it's plus or minus, but either one. You get the idea. So far, so good?
Okay, make a little new this is still 4.1, but I want you to make a new section here. Just write square root of 16 and then write nothing else. Don't even write the answer down here, because we're going to get to the answer a little bit differently. What is the square root? The exact opposite of squaring something, right? So if something had an exponent of 2 and a square root at the same time, wouldn't those things cancel each other out?
So now here's what I want you to write then. The square root of 16 is equal to the square root of 4 squared. True or false? True. That is true. Well, why write it like that? What's going to happen now? You can choose the calculator. What is the square root the opposite of? The power of 2. Those cancel each other out, don't they? So what's the answer? 4.
That principle could also work with cube roots. What's a cube root the exact opposite of? A power of 3. So I want you to write cube root 27. And then I want you to write something like what we just wrote with the square root. I want you to rewrite it and then cancel some things out. Write 27 as something to a power of 3 and then see if you can cancel some things out to find out what the answer is.
What is 27? Cube root of 3 cubed. Yep. No, that's a lot of 3s. We got to be careful which 3s get canceled. The cube root cancels what? The exponent of 3 up here, not the base of 3. But anyway, the exponent of 3 cancels with the cube root. The answer is 3. So what you're going to see in this next section of your homework is not numbers, but variables. What about this? The square root of x squared. Why is it x? The square root cancels the power of 2, so it equals x. So this is more like what you're going to see on your homework. Not just numbers, but
Also variables. Does a square root cancel out a power of 3? Or a power of 4? What does a square root cancel with? So what about, well, I don't want you to see the answer here. I want you to write the square root of x to the 4th. So the square root of x to the 4th. So the square root doesn't cancel out the power of 4 completely. Yeah, it cancels out part of it. You're right.
here's the shortcut. There's probably a whole long explanation we could go through, but just write down this little short explanation. It's really not as hard as you think. To simplify, you divide. Ooh, we're going to use some big words here. You ready? you divide the exponent. Did I lose anybody on that? You divide the exponent by the index. You divide the exponent by the index.
Exactly, yep. You're right. So let's make sure that we all know what is what. Where my pencil is pointing, what is that? Exponent or index? That's the exponent, right? The index is usually written here, but on a square root it's never really written. But what is there? A 2. So if we follow this little example here, if we could divide the 4 by 2, we're going to get 2. So the answer here would be
X squared. So even with variables in next one, it's still pretty dang easy. This is going to be a pretty easy assignment.
not that much to it. This, well, this next part you need to really pay attention to, because it can get a bit confusing. So I need your full attention here. We can still use this rule to simplify. You divide the exponent by the index. So real quick answer here, what's it going to be? Total divide 4 is 3, so it's going to be x to the third. But there's a little bit more to it. Dang it, you ready?
If I plugged in any number for x, whether it be positive or negative, you with me? If I plugged in any number for x and then raised it to the 12th power, is that going to result in a positive or a negative number? Regardless of what x is to start with, if you raise it to the 12th power, what's always going to happen? You guys, it's positive, right? Okay. What's going to happen if I take the fourth root of a positive number? The principal root. So the principal fourth root of a positive number should always be positive. Okay, so x to the 12th is always going to be positive, right? And if we're taking the fourth root of a positive number, that's also going to be always positive. If we're talking about the principal fourth root. You follow? So then what's the problem with my answer then? The answer is x to the third. That's not wrong. But what if x is negative here? If you raise to the 12th power, it becomes positive, so that's no problem. But what if, isn't this the same x as that x over here? And what if it was negative here? What's a negative raised to the third power? Something that's negative. Didn't we say that would be a problem? The fourth root of a positive something should be a positive something. But isn't there a chance this could be negative? That's a good idea. It's not really great, but that's a good idea. You guys remember something in math that I think you learned about that always makes things positive? The absolute value. Remember that? You have to put the absolute value symbol around that. What is that going to do? Make sure it's positive. Okay? So here's what you're right. And I'm going to remind you of this probably 1,000 times because it is a little hard to remember. You ready? If you take an even root and the result has an odd exponent. Oh no. There it goes. Then you use absolute value. This only applies if you're taking an even root and it comes out with an odd exponent. When When does it apply? Even root if it ends with an odd exponent. So what if I asked you to simplify the fourth root of x to the 16th? That would be x to the fourth, right? Do we need absolute values on that one? It didn't come out with an odd exponent. Even though we took the even root, it didn't come out with an odd exponent, right? What about the fourth root of x to the 20th? What would the fourth root of x to the 20th be? X to the 5th. And 5's odd, right? So what do you put around it? Absolute value bars. Only if you're taking an even root
With an odd exponent. So here's a couple of practice problems. And I think these are out of your book. So turn the page.
to 234, I believe. That's the one. Top of page 234, we're going to do the problem 3. Got it? I want you to write down A, B, and C. Problem 3.
A, B, and C.
Now, do the directions say anything about real roots? So that just means they want the principal, just the positive. Okay. So these are really easy, you guys. What's the square root of 81? And what's the square root of x to the 4th? Does that need absolute values? What do you think? We did take an even root, but did it come out with an odd exponent? So that's fine. What about over here in part B? Let's multiply by 3. A to the 4th, B to the 5th. You remember we take the exponent and you divide the exponent by the index. Exponent divided by index. Do any of those need absolute value? What do you think? No, it has an even root with an odd exponent. If they wanted the real roots, we would have to put a plus or minus in front of that 9. Do any of these need absolute values? No, because we didn't take an even root. We took an odd root. Odd roots never have absolute values. All right, what about part C? X to the 3rd, y to the 4th, but there is a slight problem here. The x to the 3rd has to be inside absolute value because we took an even root, came out with an odd exponent. So just in the case that x is negative, we would have to put absolute value bars there.
Easy peasy?
Okay, just so we can drill the nail into the coffin, I guess. You see where it says A practice? In the middle of the page? Do those ones as well, numbers 9 and 10. Middle of page 234, where it says A practice. Question 9 and question 10.
Turn real quick just to somebody by you and see what they got, see what you got.
4x, 2y.
Why does that one have to have an absolute value?
we took an even root, right? And it came out with an odd exponent. X is really x to the first power, one's odd. That one's easy to overlook. That happens all the time. So it's a common mistake. It's pretty easy to make. Just got to make sure you watch yourself on that. Question 10, though. 2y squared. Yeah. Okay. Even though this isn't going to be in the homework yet, this is another section later on in the chapter. I think it's the 4th section. I still want to make the connection now because I think it might help. Does anybody remember this from last year? This can be written like this. You remember that from last year?
No.
How do I know there's going to be a 2 on the bottom right here? Because the index goes on the bottom. Just raise your hand if this looks at all familiar from last year. This is a secondary 2 topic. So what is 4 divided by 2? It's just x squared, right? So then how would you rewrite this one? If it's the 4th root of x to the 12th, it would be x to the 12/4, which is x to the 3rd. These are called rational exponents. That's another section later on in this chapter, which we'll get to, but I'm assuming a lot of you, maybe some of you, maybe not a lot, but some of you would remember this. Right? Well, it still works with numbers. So like these examples here. 81x to the 4th inside of a square root. All that is 81x to the 4th, all raised to a power of 1/2. And all that means is it's 81 to the 1/2 times x to the 4/2. 81 to the 1/2 is just a square root. What's the square root of 81? And then 4 divided by 2. So this is what we're going to get to later on in this chapter with rational exponents. But I just wanted to show you that some of you hopefully remember. Anywho, that's it. That's the end.
So later on this chapter is